Hello students, welcome to E-Padasala. Myself Sevakumar, working as Assistant Professor 3 in Kumaragur College of Technology, Coimbatore, Tamil Nadu. Today we are going to discuss about qualitative analysis of fibers to identify in the textile area. Principally, the fibers are classified into three categories. Under natural, there are two categories. One is natural and man-made fibers. Under natural, they are subclassified into vegetable, animal and mineral fibers. Under natural fibers, there are cotton, flax, linen, and another category, that is animal fibers. There are wool, silk, like this. Under mineral fibers, there is one typical example, that is asbestos. Regarding the second category, they are called man-made fibers. They are subclassified into regenerated synthetic fibers and mineral fibers. Under regenerated fibers, there are two classifications. One is regenerated cellulosic fibers, another is regenerated protein fibers. Under regenerated cellulosic fibers, there are, we can say, viscose rayon, modal, like this. Under regenerated protein fibers, there are fibers like zein and milk fibers. Regarding synthetic fibers, there are wide variety of fibers are covered. One is polyester, next one is polyamides like nylon 6,6, like that. And another category of fibers are polyolefins. There are polyethylene and polypropylene, and acrylic and modacrylic. These type of fibers covered under synthetic fibers. Regarding mineral fibers, there are again wide range of fibers. They are called metallic, ceramic, silicon carbide, basalt and carbon. These are some general classification regarding fibers. We are coming to the next, that is qualitative analysis on different type of test. That is under one is technical test and another is non-technical test. Under non-technical test, there are two tests. One is finger sensory test, second one is the burning test. Under technical test, there are again two classification. One is the visual identification or optical identification through optical microscope or SEM or TEM. The second test under technical test is the solubility test or solvent test. We are going to see now under non-technical tests. The non-technical tests are nothing but they are either not using equipments or chemicals to identify the textile fibers. Under this topic, we are going to see first one, the finger sensory type, under which the fibers exhibit varieties of behavior when they are sensed through fingers on them through senses of warmth to cool, smoothness to rough, soft to harsh, flexibility to rigidness, properties of fibers. Feeling test is explained below. However, it is difficult to identify the blends of various fibers through this method. So, under the classification of natural vegetable fibers, cotton is sensed through fingers. We can feel them as soft and inelastic and also cool to touch. Under the same category, linen is felt as smooth and leathery and cool to touch. Regarding jute, smooth and leathery, again cool to touch. Under natural animal fibers, silk is elastic and smooth, warm to touch. Regarding wool, elastic and springy and warmth to touch. Under man-made fiber regenerated category, rayon is smooth, inelastic and lustrous, cool to touch. Under the same category, acetate is smoother, more elastic and resilient to touch, little warm to touch. Under man-made fiber synthetic category, nylon is lightweight, feels very smooth, elastic and lustrous. Under the same category, polyester is medium weight, feels very smooth and little bit stiffer. Regarding acrylic, it is like a wool but lightweight and slippery by feeling. Under the same category of man-made fiber synthetic, polypropylene extremely lightweight, resilient, smooth, and more lustrous. These are the feeling characteristics of these under finger sensory test method. We can identify qualitatively through this one. We are coming to next topic under non-technical tests, the burning test. Textile fibers behaves differently in flame based on their chemical nature and morphology structure. The natural and regenerated fibers exhibit differently in the flame based on their cellulosic and protein natures. The synthetic fibers exhibits differently based on their thermoplastic and thermoset nature. The fibers are identified through observations such as type of flame, sound and odor while burning, as well as form, hardness and color of the remnant. This is nothing but ash or bead at the following stages of flammability test. First stage is while moving the sample slowly towards flame. Second stage is during burning. Third stage immediately after being removed from the flame. Fourth stage, post burning, sample has been cooled, the ash or bead is examined for characteristics such as amount of ash, nature, form, hardness and color of the same. The burn test should be conducted with a safe ambience first. Water has to be kept near experiment place. The test should be done in an inflammable vessel or bucket made of ceramic or metal or glass, preferably with fire extinguishers like soda or even water at bottom. Contents made of thermoplastic materials should be avoided. The general burn test procedure is as follows. Hold an unknown fiber sample of at least 1 cm in length in a pair of tweezers and slowly move it toward a flame, preferably from candle, Bunsen burner or cigarette lighter even. Observe the fiber's reaction to the flame, like shrinks away, ignites before touching the flame, melts, etc. The second step is observe the fiber's reaction to being ignited in the flame, like starts to burn but self-extinguishes, or starts to burn but immediately extinguishes, or melts and burns, or melts but burns with difficulty, or simply chars like this. Then observe the odor generated by the burning procedure, like burning paper, example natural cellulosics and rayons, or acrid vinegar like acetates, and other various forms of plastic like smells. Words used such as celery, sweet, sharp, etc. may be too subjective and rely too much on individual personal experience to be useful. Observe the remaining end of the fiber under magnification where it was burned. It may be no bead or ash, easily crushable, soft, maybe brownish to black, puffy bead, hard round or irregular bead of various grey to black colors like that. It may be touched after cooling. The bead end is required to determine its degree of hardness. As for many other tests, the results should be compared with those of burn test of a known reference fiber. There are typical fiber burn charts are available. They are classified into two categories. One is burns and not self-extinguishing. Another one is burns and self-extinguishing. First one is the burn and chars. Under this, there is the odor of burning grass. Another one is the odor of burning paper. The odor of burning grass, preferably from linen, jute and hemp. And next one is the odor of burning paper. Under this category, cotton, ramie, these are all exhibiting this type of odor. Next one is the burn and melts under non-self-extinguishing. First one is the odor of vinegar, under which acetate or triacetate exhibits this odor. Next, under burns and melts is the acrylic, that is giving a odor of burning meat. So, through which we can identify the fiber. The next broad category is the self-extinguishing and burns, under which there are two categories, burns briefly and chars. Another category is the burns briefly and melts. First one is the burns briefly and chars, under which silk fiber exhibits black soft bead but odor of burning hair or feathers. The same odor exhibited by wool or even weighted silk. The next subcategory under the burns and self-extinguishing category is burns briefly and melts. First one is the nylon that exhibits odor of celery. Next one is the olefin. It exhibits the odor of burning asphalt, and regarding vinyl, it exhibits the odor of sweet chemicals including polyester. So these are the various types of odor and exhibited by this burning test. We will see the various 3 stages and 2 different observations through odor and burning remnants. Under the burning test, we will see the 3 stages of burning and 2 outcomes. One is odor, another is burnt remnant like ash and bead. First is the cotton fiber. While approaching flame, it initially scorches and ignites readily. Under flame, it burns quickly with yellow flame, and after removing from the flame, continues to burn rapidly and has afterglow. Regarding odor, it's burning with the pepper smell, and the remnant is light feathery grayish black ash for cotton, and the black ash denotes the mercerized cotton. While coming to the next natural cellulosic fiber is linen or flax. While approaching flame, it initially scorches and ignites readily. In the flame, it gives yellow flame but slower than cotton. While removing from the flame, continues to burn. Regarding odor, it is burning like pepper. Regarding the remnants, feathery grayish ash. While coming to the next category, that is natural animal fibers, that is wool. While approaching flames, it smolders, curls away from the flame. Under the flame, there is a small and flickering flame but burns slowly. While removing from the flame, it self-extinguishes. Regarding odor, light burning, feathers or hair smell. Regarding remnants, usually crushable dark ash it yields. Regarding silk, under the same category, it smolders, curls away from the flame while approaching the flame. In flame, it burns slowly. While removing from the flame, it self-extinguishing. Regarding odor, burning feathers or like burning hairs. Regarding ash, the shiny black easily crushable one. Regarding rayon, it's a regenerated cellulosic fiber. While approaching flame, it scorches and ignites. In flame, it burns quickly. While removing from flame, it is continuous to burn. Regarding smell or odor, it is like pepper. Regarding ash, it is light and grayish. While coming to next category, that is acetate, while approaching flame, it fuses away from flame and turns black. Regarding acetate rayon, in flame, it burns quickly, melts and sputters. While removing from the flame, continues to burn and melt. The smell is like vinegar, and the ash is brittle, hard, irregular black. Regarding synthetic fibers, under man-made fibers category, the nylon is fusing and shrinks away from the flame while approaching the flame. It burns slowly with melting in flame. While removing from flame, it is self-extinguishing. The smell is pungent. The bead is hard, round and tough grey bead. Regarding polyester, while approaching flame, it fuses and shrinks away. In flame, it burns slowly with melting. While removing from flame, burns with difficulty. Regarding odor, slightly sweetish. Regarding bead, it's hard, round, brittle bead. The color is black. Regarding acrylic fiber, it fuses and shrinks away from flame while approaching the flame. In flame, it flames rapidly and melts. Regarding acrylic, while removing from the flame, it continues to burn and melt. The odor is like burning meat. The bead is hard, irregular, brittle and black bead. Regarding polypropylene, while approaching flame, it fuses, shrinks away from the flame. In flame, burns slowly with melting. While removing from the flame, burns slowly with difficulty. Regarding odor, burning like asphalt. The bead is round, hard, light tan bead. So these are the 2 tests we have seen under non-technical test. Now we are going to see the under technical test. There are 2 tests. One is visual appearance of fibers. Another one is the solubility test. Now we are going to see the visual appearance of fibers through microscopes. It may be optical or light microscope, SEM or TEM. Each textile fiber has its unique morphological structure and features. So the fiber can be identified easily. When it is viewed through optical microscope or scanning electron microscope, it gives a unique characteristics. Regarding optical microscope, this is a technical test which involves identifying the fiber using microscope with a magnification capacity minimum of 100 times to maximum of 4000 times. The resolution power maximum 2500 Armstrong or 0.5 micrometer or 250 nanometers. The fiber could be distinguished between varieties of fibers. The identification of natural fiber is done easily as compared to man-made fiber. Majority synthetic fibers are similar in physical appearance, and hence identification through microscope is somewhat difficult. So we can scan through scanning electron microscope also. It produces images of sample by scanning the surface with a focused beam of electrons. The sample electrons interact with the atoms in the sample, producing various signals that contain information about the sample surface topography and composition. SEM can achieve resolution better than 1 nanometer. The SEM is working on the secondary electrons reflected from the sample surface. SEM provides detailed high-resolution images of the sample by rastering a focused electron beam across the surface and detecting secondary or backscattered electron signal. An energy dispersive X-ray analyzer called EDX or EDA is also used to provide elemental identification and quantitative compositional information. Addition to that, the resolution power is 0.5 to 5 Armstrong and the magnification power is up to 3 lakh times. Regarding transmission electron microscope, it works much like a light microscope because it works through transmission of a beam of electrons through thin specimen and then focusing the electrons to form an image on the screen or on the film. The most important difference between the transmission electron microscope and a scanning electron microscope is rather than a broad static beam is used in TEM, that is transmission electron microscope, whereas the SEM beam is focused to a fine point and scans line by line over the sample surface in a rectangular raster pattern. Under microscopic view, either through optical microscope or scanning electron microscope or TEM, we will see the longitudinal view of a following fibers. First one is the cotton. It is normally a short staple, regular and very fine fiber. Length ranges typically 10 to 65 mm. Depending upon the variety and quality, the length decides the quality of cotton yarn. A collapsed, flattened, spirally twisted convolution tube with a rough surface, a flattened, collapsed, spirally twisted in both the direction tube with a rough surface. Next one is the wool. It is regular, finer to coarser and crimped fiber. Length varies from 5 cm to 35 cm for long and coarse fibers respectively. It has up to 10 crisps per centimeter, while the finer fibers has the higher numbers. It is roughly cylindrical and multicellular in structure. The outer layers consist of scales pointing towards the tip of the fibers. Next fiber is the silk fiber. Its longitudinal view looks like natural mouth secreted protein translucent filament. The length may be up to 600 meter. However, the average length normally lies around 300 meters with a minimal twist. It has uneven and irregular surface, elliptical, sometimes twisted with longitudinal striations. Next fiber is the viscose rayon. It is a regular fine filament or staple fiber, has uniform diameter with striations or tiny grooves running parallel to the fiber axis on the surface. Next is the nylon. It is a translucent regular filament or staple fiber with smooth surface. It is usually crimped for staple fibers, delustered with titanium dioxide or texturized forms for bulkiness and a featureless longitudinal direction. Next one is the polyester, regular with a smooth surface. It is a translucent regular filament or staple fiber with smooth surface. It is usually crimped for staple fibers, delustered with the titanium dioxide or texturized form for bulkiness and still it has a featureless longitudinal direction. While coming to the next subtopic under optical visual appearance test, that is through cross-sectional view. First fiber is the cotton fiber. It is usually flat, bean-shaped, elongated or kidney shaped, has a lumen at the center and it is oval parallel to the longitudinal direction. It has diameter ranging from 11 to 22 micrometer. The length to breadth ratio or slenderness ratio is normally 6000:1 for the longest and 350:1 for the shortest and coarser fibers. Regarding wool, the cross-section varies from oval to circular with variation diameter from 14 micrometer from finest and shortest wools to 45 micrometer for the coarsest and longest wools. The innermost layer is called medulla. It is concentric and vary in size. The length and breadth ratio or slenderness ratio varies from 2500:1 for shorter, finer wools to around 7500:1 for longer, coarser wools. The central hollow canal along the central axis fiber is called medulla. It is like a lumen in the cotton. Next fiber is the silk. The larvae secreted raw filament has two triangular with rounded corners in pairs cemented by silk gum called sericin. It is in the form of cocoon, a naturally inwardly wrapped filament bundle. The breadth may range from 12 micrometer to 30 micrometer. The slenderness ratio ranges above 2:1. Next is the viscose rayon. It differs in cross-sectional view according to the manufacture process, but normally oval to cross-section while extruded in circular profiled spinneret. The longitudinal tiny grooves are the reasons for the serrated periphery. Nylon, circular, it can be manufactured with various profiles. However, the usual diameter ranges from 14 micrometer to 24 micrometer depending on the end use requirements. The slenderness ratio is above 2:1. Further, the polyester, nearly circular profile like glass rod, however, can be manufactured in different profiles. The diameter of staple fibers and the filaments varies from 12 micrometer to 25 micrometer. The slenderness ratio is normally above 2:1. The second test under technical test is the solubility or solvent test. The test involves treating the fibers in certain solvents for identifying them. The technical test is becoming difficult to conduct as most of manufactured fibers and their blends are chemically similar. There is no individual chemical or solvent test for separating or identifying the fibers in combinations. The precautions to be made during this test is: please wear the nose mask to avoid harmfulness of the vapors to the lungs, and have hand gloves, shoes and goggles to avoid harmfulness to the body. The advantage of the test is more reliable, useful for both man-made and natural fibers, can be easily conducted. The limitation is certain manufacturing finishing process like mercerizing affects the appearance of the fibers, and very dark colored fabric cannot be identified under microscope. The solvents used for identifying the various fibers are: the various solvents or chemicals are given for various fibers like sulfuric acid, concentrated hydrochloric acid. So these are the chemicals used as a solvent for dissolution of the various fibers. So based on the dissolution, we can identify the fibers. Each fiber has its own solvent. That is the uniqueness of this test. You may see in the table a particular group of fiber from the particular group, like distinguishing animal from vegetable fibers with an alkali, and distinguishing vegetable fibers from animal fiber with an acid, and distinguishing silk from wool, distinguishing nylon from other fibers, distinguishing polyester from other fibers, and distinguishing acrylics from other fibers, and also distinguishing linen from cotton through staining chemicals, and distinguishing glass fibers from other fibers. Like this, we can distinguish each and every fiber, and we can identify the specific fiber through solubility test. Let us summarize now. We have seen the identification of textile fibers through qualitative analysis under two broad categories. One is non-technical test, under which there are two categories. One is finger sensory test. We have tested the various fibers through finger sensing and brain connecting mode, through which we can identify every fiber through experiences. And next subcategory of non-technical test is the burning test. Through burning test, we had seen through while approaching flame, in flame, and after taking from the flame, also through adder and the ash or bead. Under technical test, this is another broad category. We have seen the two tests. One is visual identification test, either through optical microscope or SEM or TEM, in which the morphological structure is identified with distinguished features of every fiber. Next subcategory of solubility test, under which the solubility of every fiber is unique and through which it is identified.